Hi students, in this class we will study how to draw the three sequence networks of a given power system. How to draw the positive sequence network, negative sequence network and a zero sequence network of this particular power system. We have a generator, then transformers T1, T2 and T3, two transmission lines TL1 and TL2, then a synchronous motor is there. This is the neutral grounding reactance of the generator. Let us first draw the positive sequence reactance diagram. The positive sequence reactance diagram. We will draw the positive sequence reactance diagram of each element. Let's start with the generator. When you draw the positive sequence reactance diagram of the generator, we have a voltage source in series with positive sequence reactance. So this is Xg1. It's the positive sequence reactance of the generator G. So the voltage is Eg. Then we have two parallel branches. In the first one, we have a transformer T1. The positive sequence reactance of the transformer T1 is drawn in series with the network. In the second transformer also, the positive sequence reactance is drawn in series. It is Xt21, the positive sequence reactance of the second transformer. Then we have the transmission lines XTL1, 1. This is the positive sequence reactance of transformer 1. Similarly, in the second branch, we have this is XTL1, 1. This is XTL2, 1. The positive sequence reactance of the second transmission line. Then the reactance of the transformer T3. This is Xt3, 1. Then we have the motor. When you draw the positive sequence reactance diagram of a motor, we have a voltage source Em in series with the reactance. This is the positive sequence reactance of this motor. This is the complete positive sequence reactance diagram of this particular power system. Now let us draw the negative sequence reactance diagram. If you do some sort of modification in the positive sequence diagram, you will get the negative sequence reactance diagram. When it comes to the negative sequence reactance diagram, there is no voltage source. Except this voltage source, all other reactances will look similar, but the values should be for the negative sequence. Instead of the positive sequence reactance values, you should mark the negative sequence reactance values for each element. So this will be the complete negative sequence reactance diagram for this particular power system. Now let us draw the zero sequence reactance diagram. When you draw the zero sequence reactance diagram for a transformer, you should check the connection of the transformer, whether it is star connected or delta connected. Suppose this is the zero sequence reactance of a particular transformer. We consider this is star grounded with a delta. On the primary side, it is star with neutral grounding, and on the secondary, it is delta. This is our reference bus. Whenever you see a delta connection, you make a short circuit to the reference. Then this should be kept open. Whenever you see the delta connection, you make a short circuit to the reference bus, and this line should be kept open. Whenever you see the star connection with neutral grounding, you make the connection complete, because the zero sequence currents can flow through this neutral grounding. That's why this circuit is complete. Instead, if you consider the star connection without neutral grounding, this should be kept open. Now, let us draw the zero sequence diagram for this particular power system. Let us start with the generator. This is Xg0, the zero sequence reactance of the generator. Here you should mark, or you should consider the neutral grounding reactance also. The neutral grounding reactance Xn should be marked as 3Xn in the zero sequence diagram. We have studied the reason for that in the earlier classes. Now we consider the transformer T1. This is XT10, the zero sequence reactance of the transformer T1. On the primary side, it is delta connected. So whenever you see the delta connection, you make a short circuit to the reference bus. Then on the secondary side, it is star without neutral grounding. So this circuit should be kept open. This is not completed because there is no connection to the ground. Our next element is the transmission line. So XTL1 of 0. Then you consider the second branch. This is XT20, the zero sequence reactance of the second transformer. You look at the connection. Primary is delta. If it is delta, that side should be connected to the reference bus, or that side should be shorted to the reference bus. Look at the secondary side, it is star with neutral grounding. So this circuit is complete because zero sequence currents can flow through this neutral grounding. The next element is the transmission line 2. Then we have the transformer T3. This is the zero sequence reactance of the transformer T3, XT30. Now we look at the connection. On the primary, this is star with neutral grounding. So the circuit must be complete. The zero sequence current can flow through this neutral grounding. Whereas on the secondary side, it is delta. As it is delta, this should be connected to the reference bus. Then we have the load here. This is our motor. This is the zero sequence reactance of the motor, XM0. And this star connection is not grounded. As it is not grounded, this should be kept open. So this will be the complete zero sequence diagram of this particular power system. So now we studied how to draw the positive sequence reactance diagram, negative sequence reactance diagram, and zero sequence reactance diagram of a given power system.